Hello students, we are looking at the introduction to vectors, which is near to work. So we all know that a vector is a quantity that has magnitude and direction. So mathematically we can say a vector is a distance to which direction has been attached, or maybe we can think of it as a line segment which has been directed, or we can say a vector is a directed line segment. For example, if I have say my vector AB, how will I represent a vector AB? So if I say representation, this is a representation. So if I have a vector AB, I can draw a line segment and I call it AB. Specifically, that is a line segment. So to make it a vector, I direct the line segment so that I'm moving from A to B. So I have a vector AB. Or I can get very happy and I use small letters. I say that is my line segment. I put an arrow, shows a vector. I denote it. I name it small a. But then to show that A is a vector, I put a tilde below it. So that is how we represent vectors. We can look at the addition and subtraction of vectors. We can look at the addition and subtraction and addition and subtraction of vectors. How do we add and subtract vectors? We add and subtract the corresponding components of a vector. For example, if I'm given my vector A as equal to 2, if I'm given vector A as equal to 3, I'm given vector B as equal to 1, -3, and I'm given vector C as equal to 6, 0, and I'm told to add, if I'm told to add vector A plus vector B, what would I do? I would simply add the corresponding components. Corresponding components are components in similar positions. So I pick the vector A, which is a 2. This is vector A, which is a 2, 3, and then I'm adding their vector B, which is a 1, -3. We said we are working with corresponding components, so I'm going to have there a 2 plus 1 and a 3 minus 3, such that I have this as a 3 with 0 as my vector A plus B. Then assume I was asked also, maybe if this is Roman numeral 1, Roman numeral 2, C, vector C minus open brackets A plus B. So if I look at that, I've already calculated A plus B. So this will equal to, what will it equal to? Give me vector C, which is 6, 0. Then subtract off A plus B, which I've calculated. I've calculated A plus B as a 3 with 0, such that we still work or deal with the corresponding components. So I have this as 6 minus 3, 6 minus 3, and then 0 minus 0, such that this implies 2 or equals to a 3 with 0 as my C minus brackets A plus B. So after looking at the addition and subtraction of vectors, we can come to understanding more concepts about vectors, that is the position and column vectors. What is a position vector and what is a column vector? If I'm given a coordinate A, which is 2, 3, then the position vector of A, I'm telling A, relating it to the origin. It is A's relation to the origin, such that this means if I'm relating A to the origin, I will call it OA, such that is the position vector of A, or A, so that this will equal to, so I can convert it to what I call a column vector. So it goes to a 2, 3. So that is my position column vector. of A, which is OA.